Hello guys, in this video we will study about viva questions of strength of material. Firstly, we will cover tension and compression topic. What is the difference between tensile and compressive stress? Tensile stress is stretching force lengthens material. Is that it is tensile force which acts on body, then it increases the length of material. Whereas compressive stress is squeezing force shortens materials. Is that it is compressive force which shortens the length, compresses the material. Second, define ultimate tensile strength, UTS, and yield strength. Ultimate tensile strength, maximum stress before failure. Yield strength, stress at which material deforms plastically. How does temperature affect the tensile strength of materials? Temperature affects tensile strength. High temperature reduces strength, low temperature increases strength. Explain the concept of Young's modulus. Young's modulus measures stiffness. It is stress to strain ratio. What is relationship between stress and strain? Relationship between stress and strain can be represented as stress is directly proportional to strain. Then proportionality constant comes into play. Stress is equal to Young's modulus into strain. Now we will see the next topic, which is bending and torque. Define bending, moment and torque. Bending moment, force causing beam curvature, and torque is rotational force. Explain the difference between bending and torsion. Bending, beam curvature due to transverse load starts bending. Torsion, it is twist due to rotational force. Twist due to rotational force is called torsion. How does beam curvature relate to bending moment? Beam curvature directly proportional to bending moment. Now let us see another question. Question 4. What is the significance of the neutral axis in bending? Neutral axis divides beam into tensile and compressive zones. Describe the shear stress distribution in a beam. Shear stress distribution, maximum at neutral axis, decreases towards edges. Now let us see questions of other topic, shear and torsion. Define shear stress and shear strain. Shear stress, force parallel to surface. Shear strain, deformation due to shear stress. Third question, how does torsion affect the shear stress in shaft? Torsion increases shear stress in shaft. What is the relationship between torque and shear stress? Torque and shear stress directly proportional to each other. Describe the shear stress distribution in a circular shaft. Shear stress distribution in circular shaft, maximum at surface, decreases towards center. Now next topic is material properties. Define elasticity, plasticity and ductility. Elasticity returns to original shape, plasticity permanent deformation, ductility ability to deform without breaking. Explain the difference between brittle and ductile material. Brittle material break without deformation. Ductile material deform before breaking. What is the significance of the yield point in materials? Yield point, transition from elastic to plastic deformation. Question 4. Describe the stress strain behavior of different materials. Stress strain behavior varied responses, linear, non-linear, elastic, plastic. How does temperature affect material properties? Temperature affects material properties, strength, stiffness, ductility. Beam and column design. Define beam and column. Beam, transverse load carrying member. Column, axial load carrying member. Explain the difference between short, intermediate and long columns. Short columns crushed by compressive force. Intermediate columns buckling and crushing. Long columns buckling. How does slenderness ratio affect column design? Slenderness ratio affects column stability. What is the significance of the Euler formula for buckling, column buckling? Euler formula predicts column buckling. Describe the design consideration for beam column connections. Beam column connections. Transfer force. Ensure stability. Next topic is failure theories. Explain the maximum normal stress theory. Maximum normal stress theory. Failure at maximum stress. Specifies failure at maximum stress. Describe the maximum shear stress theory. Maximum shear stress theory specifies failure at maximum shear stress. What is the distortion energy theory? Distortion energy theory, failure by energy consideration. How does the Mohr circle relate to failure theories? Mohr circle visualizes stress states. Fifth question, compare and contrast different failure theories. Compare and contrast different theories for different materials.